Good morning, and as always,
Slow is smooth, smooth is fast.
we're going to talk about acceleration today.
So acceleration is the change in velocity. Just like velocity was the change in position with respect to time, acceleration is the change in velocity with respect to time.
So what we're going to be playing, we're going to add to our toolbox with our new term for acceleration. Our variable is really simple, it's a, but our units are starting to get more complicated. Meters per second squared.
So it gets a little challenging, but again, remember those base units of meters, kilograms, and seconds, we're still going back to those base units.
So velocity, acceleration can both be positive. Velocity is getting closer to infinity, so it's increasing, it's getting bigger. So if your velocity is from 5 to 10, that's going closer to infinity. And negative, velocity is becoming negative infinity. So if you can go from 10 to 5, you're going closer to negative infinity.
And this also works with the negatives. If you're at negative 10 to negative 5, you're getting bigger. It's still a negative value, but you're getting bigger, so that's a positive acceleration. And if you're at negative 5 going to negative 10, you're getting smaller, so it's a negative acceleration.
So our example is a car accelerates from rest to a velocity of 30 meters per second in 12.4 seconds. What is the car's acceleration? So take a moment, do your knowns, unknowns, and equations.
Great. Now if you just look at this, what we'll see is the word at rest. We know that that's saying 0 meters per second, and since the problem says the car starts from rest, or it's from rest, we know that's the initial value. It goes to a value of 30 meters per second for a final velocity, and our time is 12.4 seconds.
So our unknowns, acceleration, and change in velocity. So once again, we know that just because we are only being asked for the acceleration, we know that we need more than just to find that. We need to find the change in velocity as well. Our equations that we're going to use are the equation the equation for acceleration and the equation for the change in velocity.
Now what we want to demonstrate here in the solution is that this is that point where you don't always have to solve for delta V first if you can actually show the steps.
So we know that delta V is plugged in here, so we can rewrite our equation. We can plug in what delta V is actually equal to, 30 minus 0, and then solve from there, divide by time.
But you'll notice what we didn't do is just skip to 30 meters per second over 12.4 seconds. We showed that step, and then our next step actually shows what 30 meters per second minus 0 meters per second is in our solution.
At this point, you should be writing, substitute the variables. We're giving you the space to write in the steps for yourself. And now we've solved 30 minus 0. So we've solved for the change in velocity.
And then finally, we get an acceleration of 2.4 meters per second squared.
We'll notice that we have 2 sig figs in 30 and 3 sig figs in 12.4. And anytime you're dividing by the number of sig figs, you're going to go with the least value. So it's going to be 2.4.